You finally ended up with a working workflow on your laptop, and now you have to share your work with other people. We're going to discover a way to get consistent results using containers, and in particular creating Docker images. First of all, container is an execution instance of a containerized image. So in other words, images are the blueprint of your environments, and when you execute any kind of command inside that image, then you are running a container. So this is the first important separation: container and images. Then images are built on layers. Then, just like these games, so where you have transparent cards, you can start from the very basic layer and then proceed further, installing all the dependencies until you build your perfect picture. Well, why this is like that? Because this is a pretty good and nice efficient way to store artifacts. Meaning that if I want to push and to share my result, and on the remote storage where I want to save my files, if one of these layers, the first layer for example, already exists, usually it is for operating system and or Python or other languages, so if your base image is already remotely, you only stick with that and then you send just the additional layers. Now we are ready to go. We have understood what an image is, we only need to understand how to create this layer. There are two ways to build image layers. The first one is running a container just like we discovered last time. So you take from a registry for a Docker app an already prepared image and you run, for example, your JupyterLab image. You execute some command inside in an interactive way, and you can store the results of these actions. This is not the suggested way to proceed because it's not consistent. So you obtain a new image, of course, with all the modifiers inside, but you cannot reproduce, you cannot track what action you take to arrive to the final results. So if you want to update some dependencies or want to tweak some of the configuration, it's very hard to do. And moreover, if someone else looks into your image, it doesn't know what you did before. So we are going to look at the proper way to create an image, that is by building a Dockerfile. In other words, you need only one text file where you describe all the steps to achieve your final environment. What does it mean? You open up a Dockerfile, that means you create a file named Dockerfile, and start a series of commands. The first one is always from, so the base image that you choose. You can start from a bare operating system, or you can start from images thought for languages, so programming languages, meaning Golang or Python or whatever you can select. Or also you can start from more advanced toolset, like for example, we can start even from this SciGeekSUniverse JupyterLab image that we used in the previous episode. Good! Now we can start build on top of the from image. You should do many things. In principle, you should set environment variables, users, local folders, etc. Let's start simple. Run. The run syntax means that you can execute a command and that command will be saved in a separate layer. Every command is executed one after the other, so starting from the top to the bottom. Then you want to, for example, copy local data into the container. For example, for a demo of your notebook or for your analysis notebook that you want to store inside an image to share with other colleagues. So what you should do in that case is using add and copy command. Copy is the basic one, so it will load the file from your local host into the image, so you copy locally the files. Add has some more additional features. All the details, I will leave you the link to the documentation in the description. Usually, the execution of the run command respects what you want to install first. But for example, the very first step is installing all the heavy dependencies. And then after that, you install your little layer, your own software packages owned by you and that you want actually to share with that image. Now, without further ado, I think that the best thing is to go and touch with your hands what does it mean to create an image. So for that, we are going to have a demo of a Dockerfile, so you get an idea on how powerful are these tools. You start from the JupyterLab image that we used last time, so from SciPy notebook. Then we add a layer where we indicate that we want to install extensions. So if you look at the documentation in JupyterLab, you will discover that installing extension is simple as this. Then you have the last one, that is, okay, I'll take my notebook, very simple notebook, just like this. I save it in the IPy notebook extension. I want to import that as a default notebook for my container. So I do copy, and that's all. If I do not indicate anything, the entry point or command will be set to the parent one. So we will still use the JupyterLab command and entry point. So we do not have to touch anything. The JupyterLab instantiation will work just like the last episode, and everything will be fine. Except for you will be prompt with new extensions and a demo notebook. How to build a container starting from a Dockerfile. Pretty simple as well. We have the Docker command line, and what we do is docker build dot to indicate the context is our current folder, and the Dockerfile is present in the current folder. That's the meaning of dot, minus t indicating the name of our container. I suggest you to start directly with a meaningful name, meaning that if you want to publish your image in Docker Hub, you should start the name with your username, Docker Hub. Mine is dchangot, and slash whatever you want, a name that indicates what you're doing, just like SciPy notebook extensions. And then if you put a column and additional name, you can indicate a version for your container. So this is my first version. I can indicate v1. So you build, you start see the build process, pull the base image from remote, from the Docker app, and start building. Once done, you're ready. If you see Docker images, you can see the image with your name, probably additional layer with strange names, with strange hash. Those are the cache of each one of the layers that you put in order to arrive to the final results. Now you're ready to push your image. Push your image means taking your tag, you remember, and send it somewhere where the people can then pull again. Docker, push, and the name of your image. Now I'm uploading my image, everything went well, and if I execute again the JupyterLab, you see that I have this result. Now it's nothing else left than trying yourself. Take whatever you want, JupyterLab or your software that you are curious to import in container, and let's get started. Tell me in the comments how it goes, and see you next time.